Right, so another question which came in CSIR for 2 marks from group theory, and the question says the Mulliken symbol for the spectroscopic state arising from the free ion term Fr. So looking at the question, don't worry that how are you going to solve this question. I will teach you a very easy way to grasp that F ion term consists of these particular states but not any other states. Okay, so first thing what you should know is F term. As soon as you see this, you should correlate the F term to F orbitals. Okay, so if you correlate it to F orbitals, we know that there are 7 degenerate F orbitals. Okay, so as there are 7 degenerate F orbitals, so you should get 7 states here in the option. I mean, T is here 3, E is here 2. So 3 plus 2 is 5. So this cannot be the answer. This is 3 plus 3 plus 3, 9. This cannot be your answer. Right? 3 plus 3 plus 1. So this is 7. This can be your answer. And again 1 plus 3 plus 3. This can also be your answer. So you have eliminated A and B. Now among C and D, one of them is your options. So no one teaches us the detailed explanation that how we got this, right? So most of the students just mug up that for F term, T1G plus T2G plus A2G is the states. So how can you remember this is, as we know, S orbital is symmetric, so it is G-rayed, P orbital is un-G-rayed, D orbital is G-rayed, F orbital is un-G-rayed, right? So and we know that A1G is a total symmetric term. A1G is fully symmetric. The most symmetric state is A1G. Okay. So, but for F orbital you are getting un-G-rayed. It means there is some unsymmetry in it. Okay. So, D also cannot be your answer because F orbital has some un-G-rayed property in it. So, the right option is answer C. Okay. I hope you like this trick. This is the way I remember, because here again the options are very easy. You can easily eliminate these two, but sometimes you may get the options in which you will have again A1G, A2G and summing up answer to the 7. In that case you can simply remember that F term corresponds to F orbital and F orbital degeneracy is 7. So look for the option which has 7 whose the total states is coming out to be 7 and it is unsymmetric. So A1G is more symmetric compared to A2G. So option C is the right answer. This is just a logic. Please remember it only for the exam point of view. Okay. Now another important question which I have seen many follow some very different method to find out the reducible representation, but I'll show you an easiest way to find out the reducible representation. For that, what you have to know is characters. Character of particular matrices, like for E matrix, we know character is nothing but sum of the diagonal elements. So 1 plus 1 plus 1, 3. For C and Z, it is cos theta plus 1, 2 cos theta plus 1. For XY plane, it is 1, 1 and minus 1. Okay. When you pass a plane, like if XY plane is passed, what happens? The Z axis will interchange. That's why Z will get minus 1 and these are plus 1 and plus 1. So character is again plus 1. And I, if you perform I operation, all the coordinates changes. So all the characters are found out to be minus 1. Right. So chi is equals to minus 3. So let us find out the reducible representation for the most simplest molecule, that is water molecule. Okay. So for water molecule, now I will find out the reducible representation. Firstly, number of unshifted atoms. So on performing E on this molecule, there is no change in its geometry, right? So the number of unshifted atoms remains as 3, that is 1, 2 and 3. Now if you perform C2Z here on this molecule, so if you perform C2, what happens? The H1 and H2 will interchange, but oxygen will remain same. So 2 atoms get shifted, but 1 remains unshifted. So C2Z is 1. Again, if you pass a plane, this 2 will get shifted, but oxygen will remain as such. Again, sigma, this number of unshifted atoms is 1. If you pass YZ, YZ is molecular plane in this water molecule, all of us know. So if you pass a YZ plane, So all the atom remains as such, there is no unshifting, right? All remains as such. So number of unshifted atoms is equals to 3, right? Now what you do is, for finding out the next step, what they do is they take 3 coordinates on each atom and they rotate and do something which I do not understand. So I'll give you a shortcut for this. Okay, simply write the characters of that particular the, what do we call this, symmetry operation, and then find out the reducible representation. So character of E is 3, so write here 3, and then character of C2Z is 2 cos theta plus 1. What is theta here? C2. So 2 into cos 180 plus 1. So cos 180 is minus 1. 2 into minus 1 plus 1 is minus 1. So minus 1. Character of sigma xz or yz or xy remains same, that is plus 1. Right? And as I said, it remains same. So once you write all this, now what you do is you simply multiply this. 3 into 3 is 9. 1 into minus 1 is minus 1. 1 into 1 is 1. And 3 into 1 is 3. So these are your reducible representations. So this is one of the easiest methods to find out the reducible representations. And once you calculate the reducible representation, we know how to find out the further step, that is simply apply the standard reduction formula to find out the normal modes or any specific mode which is mentioned in the exam. Right? I hope you understand this. Right? Thank you.